The global health community is currently monitoring a significant cluster of severe respiratory illnesses linked to the Hantavirus, an outbreak that has recently emerged in the South Atlantic. On May 2, 2026, the World Health Organization received notification regarding a group of passengers and crew aboard a Dutch-flagged cruise ship, the MV Hondius, who exhibited symptoms of acute respiratory distress. As of May 8, official reports indicate that a total of 8 cases have been confirmed or suspected, including 3 fatalities, resulting in a case fatality ratio of approximately 38%. The investigation, spearheaded by the World Health Organization and the European Centre for Disease Prevention and Control, has shifted focus to the Hantavirus cardiopulmonary syndrome, or HCPS, a severe and often fatal zoonotic disease. This syndrome is characterized by a rapid progression from initial flu-like symptoms to sudden respiratory failure and hypotension. Historically, hantaviruses are classified into 2 clinical categories. Those causing hemorrhagic fever with renal syndrome, primarily in Europe and Asia, and those causing pulmonary syndrome, which are more common in the Americas. While hantavirus is typically transmitted to humans through the inhalation of aerosolized excreta from infected rodents, this specific cluster has raised international concern due to the setting and the speed of clinical deterioration. Public health officials emphasize that while these events are rare, the high mortality rate associated with the New World hantaviruses makes them a priority for global surveillance. The current timeframe of the outbreak dates back to late April 2026, with illness onset reported between April 6 and April 28. The framing of this event as a public health emergency underscores the ongoing challenge of managing zoonotic pathogens in mobile, confined environments like cruise vessels. Viewers should understand that while the general risk to the global population remains low, the biological mechanism of the virus, specifically its ability to induce a massive immune response that compromises lung function, remains a subject of intense scientific scrutiny. Unlike many other viral pathogens, the damage in hantavirus cases is not necessarily caused by the virus destroying cells directly, but by the body's own inflammatory response, leading to a condition known as capillary leak syndrome, where fluid floods the air sacs of the lungs, effectively preventing oxygen exchange. Core developments in the investigation have centered on the identification of the specific viral strain responsible for the shipboard cluster. Laboratory results confirmed on May 6, 2026, through polymerase chain reaction and genetic sequencing, that the pathogen is the Andes virus, a specific species of orthohantavirus endemic to South America. This finding is critical because the Andes virus is the only known hantavirus documented to have the potential for human-to-human transmission. The current working hypothesis among investigators from the Netherlands and Argentina is that the index case likely acquired the infection during a shore excursion in Ushuaia, Argentina, possibly through environmental exposure at a landfill or during birdwatching activities where rodent populations were present. However, the subsequent spread to other passengers and crew members strongly suggests secondary transmission occurred during the voyage. Agencies including the ECDC and the UK's National IHR Focal Point are now tracking the itinerary of all 147 passengers and crew, including 34 individuals who disembarked before the outbreak was fully recognised. The gene mystery, frequently cited in recent reports, refers to ongoing metagenomic analyses aimed at determining if recent mutations in the Andes virus genome, specifically the M segment which encodes the viral glycoproteins, have altered its transmissibility or virulence. Laboratory teams are meticulously comparing the sequence of the shipboard strain against historical samples from the Patagonia region to identify any significant genetic shifts. Despite the sensationalized claims of instant lung failure, the clinical reality reported by treating hospitals is a window of 1 to 6 weeks for incubation, followed by a sudden leak phase where the pulmonary capillaries become highly permeable. Data from the World Health Organization indicates that while early supportive care in an intensive care unit can improve survival rates, there are currently no licensed vaccines or targeted antiviral therapies available to neutralize the virus once the respiratory phase has begun. This lack of specific treatment places the burden of management entirely on rapid diagnostics and high-level life support, such as mechanical ventilation or extracorporeal membrane oxygenation, though the latter is rarely available on transit vessels or in remote clinics. Prevention and public guidance remain focused on the primary mode of transmission, contact with rodent reservoirs. Public health agencies advise travellers in endemic regions of South America to avoid activities that may stir up dust in areas where rodents like the long-tailed pygmy rice rat may nest. For those in rural or wilderness settings, official recommendations include rodent-proofing living quarters, securing food supplies, and using a bleach solution to disinfect any areas where rodent activity is suspected, rather than sweeping or vacuuming, which can aerosolize viral particles. Regarding the current cruise ship cluster, health officials have implemented strict case isolation and medical evacuation protocols to prevent further spread. The limits of current scientific knowledge are most evident in the uncertainty surrounding human-to-human transmission dynamics. While documented, it remains an uncommon phenomenon that typically requires close, prolonged contact during the early symptomatic phase of the illness. Surveillance efforts are being scaled up across the South Atlantic corridor, and clinicians are being urged to maintain a high index of suspicion for hantavirus in patients presenting with rapid-onset respiratory failure and a history of travel to endemic zones. The calm but firm consensus from the international medical community is that while the virus is formidable, its spread can be contained through rigorous environmental hygiene and rapid public health response. As of mid-May 2026, the outbreak on the MV Hondius appears to be stabilizing as the incubation period for exposed contacts concludes, yet the genetic data being gathered will likely inform hantavirus research for years to come. Scientists emphasize that the mystery is not one of supernatural speed, but of complex host-pathogen interactions that we are only beginning to decode at a molecular level. For more updates on emerging health threats and global surveillance reports, consider subscribing to this channel. At the center of the current investigation is the genetic sequencing of the viral RNA, a process that has identified specific shifts in the M segment of the hantavirus genome. This segment is responsible for encoding the viral glycoproteins GN and GC, which are the primary tools the virus uses to bind to human cells. Experts at High Containment Biosafety Level 4 laboratories are currently examining how these mutations might alter the virus's affinity for the beta-3 integrin receptors found on the surface of vascular endothelial cells. This cellular interaction is the critical first step in the pathogenesis of hantavirus pulmonary syndrome, or HPS. Unlike many other respiratory viruses that destroy lung tissue directly, hantaviruses are largely non-cytopathic. The reported phenomenon of lungs shutting down with extreme speed is the clinical manifestation of a massive systemic inflammatory response. When the virus infects the lining of the blood vessels in the lungs, it triggers an intense immune reaction characterized by a cytokine storm. This immune response causes the capillaries to become hyperpermeable, leading to a condition known as capillary leak syndrome. As the vessels lose their integrity, plasma floods the alveolar sacs, obstructing the exchange of oxygen and carbon dioxide. While recent claims suggest this occurs instantly, public health officials clarify that there is typically a biological incubation period ranging from 1 to 8 weeks, followed by a prodromal phase of fever and muscle aches. The transition from these general symptoms to full respiratory collapse is what occurs with devastating speed, often within 24 to 48 hours, necessitating immediate intensive care. To monitor the spread of this mutated strain, the Centers for Disease Control and Prevention and international partners have activated enhanced surveillance networks. These networks rely on real-time reverse transcription polymerase chain reaction, or RT-PCR, which allows technicians to identify viral RNA in patient blood or tissue samples with high precision. Hospitals in affected regions have been advised to update their triage protocols to identify potential HPS cases earlier in the prodromal phase, though the lack of a specific antiviral treatment remains a significant hurdle. Currently, ribavirin has shown some efficacy in laboratory settings but has not proven effective in clinical trials for the pulmonary form of the disease. Consequently, the primary medical intervention remains supportive care, including the use of mechanical ventilation and, In severe cases, extracorporeal membrane oxygenation, or ECMO, to oxygenate the blood outside the body while the lungs are compromised. Scientific agencies are also focusing on the rodent reservoirs to see if the mutation has changed the way the virus persists in the environment. By analysing the prevalence of the virus in populations of deer mice and other sigmodontine rodents, ecologists hoped to predict future spillover events. The mystery surrounding the genome remains a high priority for global health security, as researchers work to determine if these genetic changes could potentially facilitate human-to-human transmission, a trait currently only documented in the Andes virus strain of South America. Verification of these claims requires a rigorous comparison between the new isolates and historical data to ensure that the perceived increase in virulence is a result of viral evolution rather than a cluster of particularly vulnerable hosts. Testing at the state and federal levels continues to prioritise diagnostic speed, as the window for intervention is narrow once the pulmonary edema begins. Travel and shipping logistics are being monitored in regions with high rodent density, though official trade restrictions have not been implemented at this stage. The focus remains on containment through public awareness and the rapid identification of symptomatic individuals who may have been exposed to aerosolized viral particles in rural or neglected urban settings. Prevention of hantavirus infection remains anchored in the rigorous management of rodent populations and the systematic decontamination of shared environments. Public health guidance, issued by the Centers for Disease Control and Prevention and the World Health Organization, emphasizes that the primary risk factor is the aerosolization of viral particles found in the saliva, urine, and droppings of infected rodents, particularly the deer mouse in North America and the long-tailed pygmy rice rat in South America. To mitigate this risk, officials advise a seal, trap, and clean approach. This involves sealing any entry points in homes or storage sheds larger than 1/4 of an inch, using snap traps to reduce rodent numbers, and ensuring that all food sources are stored in thick plastic or metal containers. Crucially, the practical takeaways for cleaning infested areas involve avoiding any activity that could stir up dust, such as sweeping or vacuuming. Instead, clinicians recommend saturating the area with a disinfectant, specifically a solution of 1 part bleach to 9 parts water, for at least 5 minutes before wiping the area with paper towels and disposing of the waste in sealed bags. For those in high-risk professional roles, such as agricultural workers or foresters, the use of N95 respirators and protective gloves is considered standard protocol when entering confined spaces that have been dormant for long periods. Regarding the reported mutation, the limits of current knowledge are significant. While genetic sequencing suggests changes that may impact the speed of the host immune response, scientists not yet have definitive data on whether these mutations increase the frequency of human-to-human transmission or if they alter the virus's environmental stability. This uncertainty requires a robust surveillance framework where state and local health departments monitor rodent seroprevalence, the percentage of the rodent population carrying antibodies to the virus, to provide early warning of potential spillover events into human populations. In clinical settings, the focus is on the rapid identification of the prodromal phase, characterized by fever, chills, and myalgia, before the onset of the acute respiratory stage. Laboratory surveillance now utilizes advanced enzyme-linked immunosorbent assays to detect IgM antibodies which indicate an active or recent infection, allowing for faster triage to intensive care units. Ethically, public health reporting must balance the gravity of the high mortality rate with the reality that hantavirus remains a rare disease for the general population. The goal of sharing information on viral mutations is not to incite panic, but to ensure that the medical community is prepared for shifts in clinical presentation. By focusing on verified science and the mechanics of transmission rather than the sensationalism of instant outcomes, officials hope to foster a public that is informed, cautious, and capable of implementing effective prevention measures. As research continues into the molecular structure of this new strain, the international community remains committed to transparency and the rapid sharing of diagnostic data. For the latest updates on global health surveillance and emerging viral threats, consider subscribing to this channel.